Hi everyone, we're going to look at composition of functions as a group and then look at the example with Cayley Table. So here are three functions. We're just going to call this one F, G, and H. And we have all real numbers except 0 and 1 for our domain. So let's start composing. We'll compose F with F of X. And that just gives you f of x, because you're just plugging x into x. All right, so there's that one. The next one, let's compose g with h of x. So we write g, and here's your g, and everywhere there's an x, you're inputting h. So that's going to be g of 1 divided by 1 minus x, which equals 1. We're writing down g minus 1 over this, which is 1 divided by 1 minus x. Now what we can do is just flip this up here, and we're going to get 1 minus x, and that's just going to give you x, which equals f of x. All right, and now let's compose h with h of x. So h with h of x. So that's h with 1 divided by 1 minus x. So you write down h, which is 1 times 1 minus, and then you input your h of x, which is going to be 1 minus 1 minus x. Now, I'm going to look at this common denominator and just have a common denominator here as 1 minus x. So that's going to give you 1 minus x minus 1 divided by 1 minus x. So these ones will cancel. You can move him up there. So you're going to get x minus 1 divided by x. So you really got 1 minus x divided by negative x. And so I just multiplied the numerator and the denominator by negative 1 and made it look better. All right. So if you simplify this, this is going to be x divided by x minus 1 divided by x, which gives you 1 minus 1 divided by x, which gives you your g of x. So now what we're going to do for our Cayley table, we're going to write f of x as f, g of x as g, and h of x as h and form a Cayley table. So, and this is under composition. So we write this circular mark, and we have f, g, and h, and f, g, and h. So we already know when we compose f with f, we've got f. F with g gives us g, and f with h is h. And the same thing goes down this way. And then for this, we need g of g gave us h. G of h gives us f. And then we have f and g here. So we have to show that this is a group. So our identity is going to be, first it's closed because no new elements appeared. We didn't get any other elements except F, G, and H. It has an identity, which is F. Anytime you multiply or compose with F with G, you get G. So anytime you have, so F is your identity. The inverse is there. usually when you have your identity, you have your inverse. So basically, if you want to know what the inverses are, you would do what gives you F. So basically, we have H composed with G, and that gave you F. That means H and G are inverses. So they have inverses, and it's associative. So you can compose them and check that. So it's easily shown that this is a group. And that's it. Thank you. Have a nice day. Bye-bye.